All right, the next talk is titled Chisel Containers, given by Vladimir Petko and Pushkar Kulkarni. Vladimir is joining us online, and they'll be talking about Chisel, a new tool that automates building Distroless containers. Over to you, Pushkar.
Thank you. I'll be delivering most of the talk, and then if there are questions uh, which I can't take, then Vladimir is here to take those questions. So I'm not going to go into the presentation mode because there's a couple of, I want to switch between the browser and I actually was hoping to do a demo, but I thought it would be better to go with the video because of the lack of time, and the demo gods are not always kind. So, so the agenda is just an introduction to what chiseled containers are. We'll actually see two short demos. Do a discussion, and then there's a conclusion. So we start with what slices are. This is the definition of slices. So a package installation is, in a practical sense, it's a set of files which are installed on your system. So can you divide that package into logical subcomponents? Of course, that depends on your knowledge of the package. So if you can divide the package into logical subcomponents, which is basically logical groups of files, we can call them slices of that package. So for example, if you take the libc package, you can divide it into a config slice, which has a group of configuration files, and you can have another slice called libs, which has, of course, all the shared objects. So this is an example of a slice of the same slice definition. We use YAML for that. So you can see the package name mentioned there on line number 1, libc6. And you have the slice definitions after that: config, the contents of config, libs, and the contents of libs. Now, we have some common slice definitions at the Chisel releases repo. So I'll just switch to that. Sorry, I'm not able to mirror the screen here. Yeah, so this is the Chisel releases repo, and there are a bunch of slice definitions. And the one slice definition that we are interested in for this talk is the OpenJDK 8 GRE headless slices. So the package name is OpenJDK 8 GRE headless, and we have divided that into a lot of slices. So we have something called the core slice, which is the slice which gives the core functionality. These are the contents of the core slice. We then have the locale slice. We have the security slice. We have the AWT slice. This is in the context of Java 8. We have the management slice. And if you see, there is a section called essential here. And this is where we list the dependencies. Now, slice dependencies are basically dependencies between slices, just like you have dependencies between packages. We define dependencies between slices. And the format for the name of a slice is the package name underscore the slice name. So here you can see for the management slice, you have an internal dependency to the core slice. And so it is for JFR. If I go up and see okay, let me go to the core slice. If I go to the core slice, it has some slice dependencies which are external. They don't belong to this package. So I have a libc6 libs dependency and some other slice dependencies. So these are examples of external dependencies. So slice dependencies can be both external and internal. So I think that's what the next slide talks about. Yeah, we saw that. We saw the core slice of OpenJDK GRE headless, having slice dependencies to a couple of external slices, and then the security slice, depending on one external slice and I think both external slices. Both of them are external slices. But you can have a mixture of external and internal dependencies. So I think we'll just dive into a demo now. So I'm going to just play this screen capture which I did yesterday. So these are the typical images that OpenJDK images that we use for Java. So I mean, these are not the only images. You have a lot of options, but just to get an idea of what the size is like, typically an OpenJDK 8 image would be somewhere around 321 MB, and an OpenJDK 11 image would be somewhere around 440 MB. Of course, there can be images which are lesser than this in size, but then let's see what we can do with slices and chiseled images. So I am downloading, so this Ubuntu Rocks Chisel JRE is the project the project for this particular demo. So I just cloned that. I'm seeding into the directory, and there is a Docker file here for 2204. Now let me open that Docker file. Now this is, this project uses the OpenJDK 8 GRE headless slices. And this is a Docker file written for that. And here you see, in the beginning, we are actually downloading an image called, it's a Golang image, which has a tool called Chisel. Actually, we are downloading, we're cloning the Chisel repo and building the tool. So I'll come to that later. And then, here you see we use the Chisel tool, and we do a chisel cut. I'll come to what -- release means, what -- root means, and this is where we are listing the slices. So this is, we are telling Chisel that we are interested to build an image with all this particular list of slices. So I'll do a Docker build now. That's going to take a while, so I'll just fast forward. Yeah. So I actually did a Docker image list after the image built, and you can see the size of the latest built image is 105 MB. Yeah, and that just to prove that it's a Java 8 image. Now, what you can do is you might not always need all the slices. Your application, for most of the times, might just need maybe core and security. Maybe JFR is something you might want to use in development, but when you are deploying, you might not want to use JFR. So let's do, oh, what happened? Okay, so now I'll try to delete a bunch of slices. I'm actually going to just keep core. So just JRE headless core and rebuild the image. That should finish in a few seconds. Yeah, and I think now we'll have an image with a much reduced size, and that is 92.2 MB. So by reducing the number of slices, we just reduce the size of the image. And just for sanity, we're just running that. Yeah, and it's an OpenJDK 8 image. Okay, so now let's get back to the deck. So we saw a chiseled JRE using OpenJDK 8 slices. Okay, now let's talk about the Chisel tool. So the Chisel tool is the protagonist here. So once we have slice definitions, we can use the Chisel tool, and the most important thing is the release. So these images are based on a release. So the image that we built was based on Ubuntu 22.04. So that -- release actually tells Chisel where to look for and which distribution to depend upon. And then the -- root just tells it which directory to use as the root FS. And after that follows a list of slices that we are interested in. -- release, whatever is given as the -- release is called a database of slices. So the Chisel releases, repo is what the database of slices is. So in this case, in the Docker file that we used, we actually cloned Chisel releases, and we pointed to the directory where it was cloned as the database. So the Chisel tool is not yet released. I mean, there is no binary which is available, so that is why we cloned. We had a Golang container. It's written in Golang, and we cloned Chisel and we built Chisel, and then we used Chisel. So that's what we did in that Docker file. So Debian packages have maintainer scripts. So there is no support for maintainer scripts when it comes to slices and chisel images, but there is a replacement in the form of starlock mutation scripts. So you can see there is a base password package slices definition, and at the bottom you can see a section called mutate. So you can write mutation scripts using starlark. Again, this is altogether a different topic, so I'm not going to dive into that. Now let's talk about the benefits. First of all, there is a reduction in image size. I'm not sure if that picture on top is clear, but the chiseled Ubuntu is the third in that picture, third from the left. Of course, that's also third from the, no, that's, yeah, third from the left, sorry. So we have reduction in the image size, because of which there is a reduction in the cloud footprint. There is a reduction in the network transfer time, reduced bills, smaller carbon footprint. But the more important part is the next one, which is Distroless with prominence. So I'm not sure if you've heard of Distroless images from Google. So Google came up with this idea of Distroless images. So what actually defines a distro or distribution? It is the package manager and the shell. So if you strip off the package manager and the shell and have images which are tailor-made just to do one thing, they are good at, I should say, they can do just one thing. Those are, those were called Distroless images. So Distroless images reduce the need for updates, because you just have, or you just you just have whatever you absolutely essentially need, and that also means there is lesser maintenance stress, and there is a smaller attack surface. So if there are CVEs, you would want to have CV updates only for the packages you have. So those are in short the benefits of Distroless. But here with the chiseled images, Distroless comes with prominence. Now what do we mean by that? Now chiseled images are based on a distribution. Though there is no package manager, there is no shell, they are built using a known distribution, using a package manager of that distribution. So we have that distribution's package ecosystem to fall back on. And we can establish a chain of provenance, which means we know how the image was built and from what versions of different packages the image was built. So this is the biggest benefit of chiseled images or chiseled containers, and we call it Distroless, but with provenance. The current limitations are we're just supporting Ubuntu archives for now. There is a pull request up to support Debian archives. We are still working on release and cache validation, which means the part where we prove the chain of provenance using GPG signature validation. So when a package is downloaded, either from the archive or from a cache, we have to be sure that it's genuine. It was not modified by something like a man-in-the-middle attack. This is available only for AMD 64 and ARM 64 for now, which I'm not sure if that's we can call it a limitation. The biggest problem is the effort. Now this is a one-time effort, which one has to put in writing a slice definition. This needs a very thorough understanding of the package. So all of us know package-to-package dependencies, but here those package-to-package dependencies need to be translated to file-to-file dependencies or slice-to-slice dependencies. So there are some tools which help us with this. So Vladimir has written a package tracker tool, which I have linked in the references, so you can take a look at that. Then there is the list dynamic dependencies utility, and of course, you can do code reviews to understand the package. So with JREs, I mean, if you're doing a Java 11 or above, if you're creating an image of Java 11 or above, you can also use the JLink tool, which I'm not going to go into now. I had that demo again, one more demo. JLink is very specific to Java. It's available with Java 9 and above. But with JLink, you can reduce the size of the JRE further. You can just pick and choose modules that you want. So JLink plus chiseled images, that helps you reduce the size of the image further. Okay, so coming to the conclusion, containers should be as small as possible. We prefer we prefer self-contained appliance-like images, which are built to do only one thing. We don't want, at least in production, we don't want containers or images which can do more than one thing or which can do a lot of things. Chiseled images offer the advantages of both a Distroless image and a distribution-based image. There are advantages of both. So chiseled images are like, they offer the advantages of both these things. A nice place to start is the do-it-yourself chiseled Ubuntu blog post, which is also linked from the references slide here. So that's it. We'll be happy to take questions.
So we are quite out of time, but maybe we have time for one question. Do we have any questions? All right. Thanks very much.
Okay. Thank you.